afternoon. I am Han from iddp second group. Today we're gonna present the big aerodynamic characteristic experiment. So the experiment objective is to find the CLCD and CM at leading edge and the CM at the counterpart. Also provide us the angle of store angle of attack and error too. Here is the airfoil. So the airfoil contains four components, which is chord line, which is the horizontal line here, and the main camber line, which is the dash line here. So the length between chord line and camber line here we call camber, and the thickness is here provided this length. So now we will introduce about the NACA 4-digit series, which is the first digit contain the maximum camber, and the second digit contain indicate the position of the maximum camber where it's out, and the last two digits is the maximum thickness of the airfoil. So moving on to the graph here. So as you can see, the CL will increase as the alpha increase until reach the maximum point here. We call this point at the stall point. And so how can we measure the wind speed? We can measure wind speed by calculate from this formula, because our wind tunnel can measure only the pressure difference PT minus PS here. So how the wind tunnel measure PT and PS? Here we go. This is the pitot tube. So the pitot tube can measure the stagnation point here, which is the PT, and the static point here which measure the PS. Then we can find the pressure difference too. So as we get the pressure difference here, we can plug into this formula, and then we get the wind speed here. Thank you.
From this experiment, we will get this parameter with its angle, pitching moment, lift, drag. And then, in order to plot the curve, we must change this parameter into non-dimensional parameter by changing it into the lift, drag, and moment coefficient. After that, we plot this value versus the angle that change due to the time, and we will get the graph, three graph, which is lift coefficient versus angle of attack, drag coefficient versus angle of attack, and pitching moment coefficient versus angle of attack. Then from the lift coefficient curve, we can analyze the angle of the incident by look at the x-intercept. In this experiment, we know that we use the symmetry airfoil NACA 0012, and if the angle of incident of this airfoil equal to 0, the curve will intercept at the origin. However, from this curve, it seems to have the x-intercept at 4 degrees. Hence, we can conclude that the angle of incident is equal to minus 4 degrees. From this graph, we also see the effect of the different Reynolds number from two experiments. The second experiment that we test at higher Reynolds number will give the higher slope of the CL alpha curve. We can conclude that the higher Reynolds number will result in the increasing of the lift coefficient. Let's move on to the drag coefficient versus angle of attack. At this graph, we can see the effect of Reynolds number, which is the higher Reynolds number means the lower drag coefficient, that we can see the orange line from the second experiment. For the third graph, which is CM alpha curve, we can see that the higher Reynolds number from the second experiment, which is the orange line, will give higher slope of pitching moment coefficient, as you can see in the orange line. So we can conclude that the increasing of Reynolds number result in increasing of pitching moment.
This machine is a closed air tunnel. It's used to find wing distribution by given data as a normal force and axial force that act on this wing. Two of my friends are recording this data. First person on the right, he read value from the machine. Another one on the left, he put value on Excel for calculating later, so we can plot coefficient lift and coefficient drag as a graph. Another one who sits under the wing has role to change angle of attack of this wing. And finally, we will get the data as shown. in this table on Excel. After that, we can plot the graph as my friend already presented before. And the last guy who sits on this control panel, he has a role to change airspeed in wing tunnel. So we can have two lines in coefficient lift efficient drag graph because of two Renault number.